Hello, this part we will talking about the field testing. The meaning of field testing is that for the previous part we have to make the hole, we get soil sample, and after that we send the soil to test in the lab. We test for so-called unconfined, test for the other laboratory tests that you studied for the previous semester. So in this part we're talking about the field test. What is the field testing? That we conduct the test in a field. After we conduct a test in the field, we can get the results immediately, and after that we can use the results for design a foundation. So in this course we're talking mainly about SPT and main shear and CPT. According to before the field test, before I talking about the field testing, I will talking about how can we analyze it, how can we decide the foundation. It's about 1920. It's about very long time ago. If we are the civil engineering, we have to decide based on judgment. That means if you would like to decide some kind of the foundation, you have to try to refer the previous case study that you have done it before in the past. We cannot have any kind of calculation, and after 1940 they can have the so-called laboratory testing. So when we like to decide something, we have to combine laboratory testing, and also we can have the last part is so-called in situ testing. We have first one judgment, second one lab, and the third one is in situ testing. The in situ testing, for example, is quite easy to understand what's going on. If you would like to construct something, okay, you for example you would like to construct some of the building. Here you have to test it before. In the field, maybe you just put some of the concrete in the field and create some of the stress the same magnitude to your building, okay, and see what's going on. Maybe in the field, maybe it have some failure or not. If have no failure in the field, we can extend the results to the bigger one as the actual building or actual construction project, such as we like a long time ago the Roman Empire can construct about the Colosseum, can construct a lot of wall and road by using is so-called the in situ testing. And after about 1940, the increment of laboratory testing, they increase a lot after they have the theory that proposed by one guy for the daddy of the soil mechanics. It's so-called, his name is Karl Terzky. He proposed the effective stress theory. So we have a lot of testing, and right now currently you can see that the trend is changed again. The laboratory testing will disrupt by field or in situ testing. And right now maybe it becomes smaller and smaller, and we still have the other method for analysis. We have the theoretical model, or right now we use a lot of so-called finite element method to design of the foundation, and we have the probabilistic method also for design. So you can see the trend right now. The field in situ testing is increased a lot. Right now I always use the in situ testing for test for the soil. Lab is just like a backup data, or in some case we can use lab. We'll be talking about this one later for the next week. How can we interpret the soil testing result? So the first in situ testing or field test I will talking is so-called SPT. S standard penetration test. Standard penetration test. What is a standard penetration test? As I talking about how if we would like to collect the sample by using the split spoon or split sample, we have to dry the sample into the soil. Have to dry it to dry by using the hammer. We move the hammer up and we let it fall to hit the base around here, and it's knock it on. And instead of we using the hammer, we just set this one as the standard penetration. What is standard penetration? We have to specify the item for standard is the weight. It's the weight of the hammer. We have specified the height, drop height of the hammer. One is weight, second one is drop height. And the method, how can we test? We have to specify the diameter of the rope. Is the mandibular rope diameter is 25 millimeter, and they have the cat head. They have to rotate about cat head is about 2.5 round. 2.5 round. Then this is pull it together. This one is standard penetration, and when we test, we have to count. It's so-called count the ball. How many blow that occur in your test. So that make the conclusion for SPT. SPT is that we have to elevate or lift the hammer. The weight of the hammer is about 60 kilogram, and falling height is about falling height is about here is about 26 centimeter or 30 inches. Okay, to lift it up, and we have to test in 3 interval. Okay, and we draw some 3 interval. We have the ground level. Okay, and we blow it by hammer. Move this one up a little bit. This one is a rod extend. Okay, and after that we blow this one move down. We have to mark about 3 interval. 1, 2, and 3. Each interval length is about 0.15 meter. When they hit for this interval, they use only 2 last intervals. So that means the first interval we neglect. Okay, we count the blow only the final last 2 interval. This one, length of this interval is about 1 foot or 0.3 meter. So that's when we count the blow of the hammer on this. So the unit of the blow is blow per foot. The meaning of blow per foot is that if you would like to penetrate your sample into the ground about 1 foot, it requires how many blow of the hammer on the base plate. For example, it said in the practical they said n equal to 30. 30 is mean 30 blow per foot, or we can say 10 blow per foot. So that means when you conduct the SPT test, you have to count. You have to count the hammer hit on the area or on the base plate around here. You have to count how many blow that penetrate the sample per foot. So the meaning of SPT is that is the how many blow of hammer per foot. How many blow of the hammer per foot of the testing. If you have higher n or higher the blow number, that means the strength of the soil is maybe it's quite high. On the other hand, if you have the number of the blow maybe really low, that means the soil is soft or strength is really low. Is that clear? For SPT, when we collect, if you said you would like to collect the sample by using the SPT, that means you're using the SS or split sample. If you forgot about this one, please go back to watch my previous video. Split sample, so that means you obtain about the disturbed sample. If the disturbed one, according to the grading of Eurocode, you cannot use this sample to test for the strength test, for stiffness test, and the other test also, because the quality of sample is not good. And the SPT actually is depend on machine and operator. Machine and operator is something like that. You can see they have a lot of energy loss. Where it should be lost around here. It's from the rope and the pulley here, and this one can be energy lost, and energy loss also, a lot of energy loss. So in SPT, according to the research, they found that the energy that actually applied to the test is only about 60%. If you read from textbook or the standard, they always said they use notation that N60. N60 is that the SPT that energy lost about 40%, they have the energy left is about 60%. So that means it depends on the type of the hammer, depend on the machine. So the result of SPT is quite scattered compared to the other field testing result. And also they have many types of the hammer. This one is quite popular. It's so-called safety hammer, and we have the donut one, and we have the pin weight one. But the concept is quite the same. Is that they use the weight about 63.5, and the drop height should be set as the standard. So how can we test? I will not talk about this one in detail. I will talking about how can we calculate the strength parameter from SPT. Firstly, before we get the soil, there's the result in the field, we have to classify whether your soil is clay or sand. How can you know clay or sand? We know from so-called the sieve number 200. Okay, if it's passing through 200 more than 50%, is so-called clay. If the soil particle of soil retained on the sieve number 200 higher than 50% is sand. How can we classify? We have to get the result from the sieve number 200. When we classify the soil and sand, we have to calculate the strength parameter. So how can we calculate? For the first one, the parameter you calculate from the test. If you classify that your soil is sand, for practically we assume that the coefficient equal to 0. We have to obtain the friction angle from the test. So the first approach is proposed quite a long time ago, 1974. A long time ago, it's from Bex. Bex is from US. Bex approach, we use the chart. The first way we have to make the so-called correction of Bex. We have to correct in case that if, right in computer way, n is more than 15. We use this equation to make the correction. For example, if my n equal to 17, so n correct is equal to 15 plus 2 over 2 is same as 45. So this means this one equal to 16. What is the unit of SPT? Unit of SPT is bro per foot. After we make the correction, you can use this curve, but please remember is that if the n lower than 15. N lower than 15, we have no correction. We have no correction. So how can we use this curve? We just obtain from each one the n correct, and we go this way, and we go beyond up to this here. So that means now you can obtain the friction angle of this one. The problem of this, because this one is quite long time ago when they try to calibrate this curve, they have really the effective stress that they apply in the chamber that is quite low compared to the foundation right now. Right now we have the really long pipe in Bangkok. The length of the pipe is about 50 to 60 meters. So that means effective stress of the pipe is really high. So if you use this chart with the high effective stress case, the results might be earlier. So they have the upper bound of this chart that the fee get from this chart should not higher than 35, because they have no effective stress calculation from this chart. If we have really high effective stress, we have to change to we use this one. This one, that means we have the N here. N here is have set non-correct. N here is N60, that means no correction. Divided by effective stress. So how can we use this one? We just move it up to it here, and then after that we can calculate for friction angle. It's quite straightforward. The difference between Parry approach and Beck approach is that for the Parry approach we have to calculate for the effective stress. This one is not quite popular because the engineer would maybe, I don't know why, maybe they're quite lazy to calculate for effective stress. So this chart is more popular compared to the Beck approach is quite popular in Thailand compared to the chart with Parry. But right now you have you have the computer, you have Excel, you can write your code in Python too, right? I think in the future this one is more popular compared to the Beck approach. This one is not, actually is still old, also 1977. I'll be talking about this one later. How can we, for example, how can we calculate in the soil boiling interpretation? For the next one, we talking about how can we, if we see our soil is clay. Actually for Bangkok clay, they have the chart that proposed by Dr. Surachat Sampantharaksa in Chulalongkorn University 1985. They said they just quite straightforward, just in here, then move it up, and they get the result from QU. So what is a QU? QU is unconfined compressive strength. If you guys can remember, QU over 2 equal to SU. The reason is something like this. If you have the test result, you have the shear, you have the stress, and have the Mohr circle. This one is, I think you guys can remember about this. I hope. I'm not quite sure you still remember this. And this one is SU. Okay, QU over 2 equal to SU, or diameter equal to QU is diameter, SU is the radius of the circle. And Dr. Surachat, he proposed into category. The first one is CL, and the other one is CS. What is the CS and CL? CL is the liquid limit is lower than 50%. CS is liquid limit is more than 50%. So that means if you would like to use this chart, you have to know the value of liquid limit. So in the practical way, people always use this one. So if you try to make it easier, this one is a ton per square meter. It change to be SI unit. Become QU equal to maybe just approximate to 4 kilonewton per cubic meter, or we can calculate SU equal to 5.2 kilonewton per square meter, or approximately we use SU approximately 5 N with units kilopascal. So that means if you, from according to this point, if you have the result of the SVT, the proper force, just multiply N with 5, you can calculate the value of the unbent shear strength. It's quite straightforward to calculate. Let's make the conclusion of SVT. The first one, cohesion equal to 5 N. You can calculate the strength for clay. So for today, you can, right now you know the way how can you calculate the strength of sand by two methods. The first one from PEG, the second one is the equation for Parry, and you also know how to calculate the strength of clay by using N value multiplied with 5. N value is the N60, no correction at all, not correct at all, just use the result from the test and calculate this one. So how to classify the soil, we're talking about this one later. How can we interpret the soil results from the figure? And you have the name or tell the stiffness of the soil is something like that. If the result of the unconfined compression test is a U3 test, is the QU from 0 to 25 we call very soft clay, or N 0 to 2 very soft, medium, stiff, very stiff, and hard. And also for the cohesionless soil, it depends on the DR. DR is the relative density. Relative density. If DR equal to 100, that means it's dense. It cannot denser than this certain value, and 5% is that means it's a 5% compared to the densest state or the 100 state. So 0 to 5 very loose, 3 to 5 to 30 is become medium, and dense it may be 60 to 95, and it is also depend on the N value. N value here is non-correct N value.